friends, this is Mona Jhunjhunwala and our topic for today is squares and square root. You have studied now what is the meaning of this? This means 3 raised to the power 2 which is equal to 3 into 3 which is 9. Now if I have 3 to the power 4, I will not use a specific name for it, but for this power 2 we have a special name called square. So this is 3 to the power 2 or 3 square. Same way, minus 3 whole square means minus 3 into minus 3. Now minus into minus is plus, 3 into 3 is 9. So we again get 9. We realize that 3 square is 9 minus 3 square is also 9. Now what can you say about a square? Square of a number is the result obtained on multiplying a number by itself. Okay, now if you have a fraction, say 2 by 3 and you square it. In this case, the numerator and the denominator have to be squared separately. 2 square is 4. What is 3 square? That is 9. So we are getting 2 by 3 whole square is 4 by 9. Same way, we can also find the square of a decimal number. If I give you a decimal number 0.2 whole square, then how will you find its square? 0.2 whole square means 0.2 into 0.2. Now, after decimal, there are a total of 2 digits. So, our answer is 0.04. After decimal, we are getting 2 digits in the square, but in the given number, there was only 1 digit after the square. So we realize that when we square a decimal number, the number of digits after the decimal get doubled. Let us discuss about squares of natural numbers from 1 to 10. Now 1 square is 1 into 1 which is 1. 2 square is 2 into 2 which is 4. 3 square is 3 into 3 which is 9. 4 square is 4 into 4 which is 16. 5 square is 5 into 5 which is 25. 6 square 36. 7 square 49. 8 square 64. 9 square 81 and 10 square is 100. Can you see any pattern in these squares? Let's find out if there is anything which is common in all these squares. Just see, this is ending with a 1. 1 square is ending with a 1 and also 9 square is ending with a 1. 2 square is ending with a 4. Also 8 square is ending with 4. 3 square ends with a 9. 7 square also ends with a 9. 4 square ends with a 6. 6 square also ends with a 6. So we realize that when we square any number, what we get as the last digit is 1, 4, 9, 6, 5 or 0. So which are the digits which are not present at the end of these squares. The digits which are not present at the end of these squares are the digits 2, 3, which other digit is not present here? 7 and 8. So we come to understand that the square of a number can end with a 1, 4, 9, 6, 5 or 0. A square cannot end with 2, 3, 7 or 8. Can you see any other property over here? Just see, 1 square is ending with a 1, 3 square is ending with 9, 5 square ending with 5, 7 square ending with 9 and 9 square ending with 1. These all numbers are odd numbers. So we come to understand another property for squares of numbers. Numbers which end with an even digit are even, and numbers which end with an odd digit have an odd square. We can see that squares of odd numbers are odd, whereas squares of even numbers like 2, 4, 6 are even. Let's talk about squares of numbers ending with a 0. 10 square is 100. Okay. What is 20 square? 20 square gives us 400. You can see that 20 square is 20 into 20. So we are getting 400. Now the number of zeros in 20 is 1. But in 400 we have double the number of zeros which we had in 20. So this is another property of squares. When we square a number ending with a 0, the number of zeros get doubled. Okay, now let's look at this. This is a fraction. The square of 2 by 3 is 4 by 9. What is 2 by 3? 2 by 3 is 0.6 something. It's approximately 0.6. Okay. What is 4 by 9? 4 by 9 is, tell me, 4 by 9 is 0.4 something, 0.44. Okay. So you can see that when we square a fraction, the answer is less than the fraction itself. Same way, when we are squaring this decimal number, is 0.04 less than 0.2? Yes. So we come to understand another property of squares, and that is square of a fraction is less than the fraction itself, as well as square of a decimal number is less than the decimal number itself. We had discussed that square of -3 is 9. Square of 3 is also 9. Now, suppose I ask you to find the square of -4. Square of -4 will be -4 into -4, which is 16. So we come to the conclusion that squares of positive as well as negative real numbers are positive. So a square of a real number is always positive. Fine. Now let's look at 4. Suppose I divide 4 by 3. What is the remainder that I get? The remainder that I get is 1. Okay. Now if I divide 9 by 3, remainder is 0. If I divide 16 by 3, remainder is 1. If I divide 25 by 3, remainder is 1. If I divide 36 by 3, no remainder, remainder is 0. If I divide 49 by 3, what is the remainder that I get? The remainder is 1. These are all perfect squares, so I am getting the remainder as 0 or 1 when I am dividing them by 3. We come to the conclusion that on division by 3, if we get 2 as a remainder, then the given number is not a perfect square. Same way, when a number is divided by 4 and the remainder is 2 or 3, then the given number is not a perfect square. Okay, now let's look at the squares of 4 and 5. Square of 4 is 16, square of 5 is 25. 5 square is 25. 4 square is 16. 4 and 5 are two consecutive natural numbers, and if we find the difference of their squares, we are getting 9. What is 5 plus 4? 5 plus 4 is also 9. Now, is it a coincidence that this answer is 9 and also 5 plus 4 is 9? No, this is not a coincidence. You have studied a formula in algebra which is similar to this. Which formula is that? Can you tell me? The formula is a square minus b square. A square minus b square is a plus b into a minus b. Now 5 plus 4 is 9 and 5 minus 4 is 1. So we are getting that the difference of the squares of two consecutive natural numbers is the same as the sum of the given natural numbers. Now, which is the smaller natural number out of 5 and 4? 4 is smaller than 5? Okay. Now, how many natural numbers are there between 25 and 26? We can calculate using the formula 2n, where n refers to the smaller natural number. So we are getting 2 into 4, which is 8. If I ask you directly, how many numbers are there between, how many natural numbers are there between 25 and 16? What do? You will write 25 minus 16 minus 1 to find how many natural numbers are there between 25 and 16. So we are getting 8. To find how many natural numbers are there between the squares of two consecutive natural numbers, we can directly use the formula 2n, where n represents the smaller of the two consecutive natural numbers. Okay, now let's study about another property. Let's take any two consecutive odd natural numbers, for example 7 and 9, and let's find what happens if we find their product. So 7 into 9 can be written as 8 minus 1 and 8 plus 1, which is 8 square minus 1 square, which is 64 minus 1, which is 63. The product of two odd numbers or two even numbers which are natural is 1 less than the square of the natural number which is in between the given natural numbers. Okay, we have studied that 1 square is 1, 2 square 4, 3 square 9, 4 square 16. You can see that 1 is 1, 4 can be written as 1 plus 3, 9 can be written as 1 plus 3 plus 5, 16 can be written as 1 plus 3 plus 5 plus 7. Is there any pattern which you can see between these numbers? Yes, they are odd numbers, and 1 is 1, 4 is 1 plus 3, sum of the first two odd numbers. 9 is the sum of the first three odd numbers. 16 is the sum of the first four odd numbers. The formula for directly finding the sum of the first n odd numbers is n square. So if I have to find the sum of the first two odd numbers, I can directly use 2 square, which is 4. If I have to find the sum of the first three odd numbers, I can use 3 square, which is 9, and so on. M is a natural number, then 2m, m square minus 1 and m square plus 1 forms a Pythagorean triplet. You all have studied Pythagoras theorem and Pythagorean triplet. So what happens when we have numbers like 3, 4 and 5 as a Pythagorean triplet? 5 square is equal to 3 square plus 4 square. M has to be a natural number greater than 1. So if I take M as 2, I get 2 into 2, which is 4. M square minus 1, 2 square minus 1, which is 3, and 2 square plus 1, which is 5. 3, 4 and 5 are a Pythagorean triplet. Same way, if I take M as 3, I get 2 3's are 6, 3 square 9, 9 minus 1, 8, and I get m square plus 1, 3 square plus 1, 9 plus 1, which is 10. So the first two Pythagorean triplets are 3, 4 and 5, and 6, 8 and 10. Let us learn how to find the square root of a natural number by prime factorization method. If you have to find the square root of 324, you have already learned the prime factorization method, which you have been using since class 4. Okay, so here we'll be writing only prime numbers because we are using prime factorization method. Let's start with 2 and keep on dividing by 2 until we can. So 2 1s are 2, 2 6 are 12, 2 2s are 4. Again we can divide by 2. 2 8s are 16, 2 1s are 2. Now 81 is not divisible by 2, so let's try to divide it by the next prime number, which is 3. 3 into 27 is 81. 3 into 9 is 27, and 3 into 3 is 9. Now we need to find the square root of 324. we use this radical sign for square root. Square root of 324 is, let's write all the prime factors which we got over here, and the prime factorization of 324 is this. Now when we find square root using prime factorization method, we make pairs of the numbers which are same. So we have two 2's over here of which we'll make one pair, 3 into 3 another pair, and 3 into 3 another pair. So we have made 3 pairs, one of 2, another of 3, and also another of 3. Now 2 3's are 6 and 6 3's are 18. So square root of 324 is 18. We can say that 324 is the perfect square, and it is the perfect square of 18. Okay, now let's take 325. It's not divisible by 2, right? Not divisible by 3 also. So let's divide by 5. 5 6 are 30 and 5 5's are 25. Again let's divide by 5 and we get 5 1's are 5, 5 3's are 50. So square root of 325 is square root of 5 into 5 into 30. The 5's have a pair, so when we have a pair, one of the numbers can come out of the square root sign and we get 5 into root 13. The root sign has not gone away from the square root of 325. So we can understand that 325 is not a perfect square. Square root of 325 is 5 into root 13. Okay, now suppose in an auditorium there are x number of rows and equal number of columns. So total, how many number of seats will be there in the auditorium? In the auditorium, total number of seats will be number of rows into number of columns. So we have x into x square number of seats in the auditorium. And if it is told to us that the total number of seats in the auditorium is 676. If the total number of seats in the auditorium is 676, then can you find the value of x? Yes, you can. How will you do it? X square is 676. If we take square root on both sides, if we take square root on both sides, we get x equal to square root of 676. By calculation, you can understand that the square root of 676 is 26. So there are 26 rows and 26 columns in the auditorium, meaning that there are 26 rows, each having 26 seats in the auditorium. Is 325 a perfect square? We can see that when we find the square root of 325, we are getting 5 into root 13. This 13 does not have a pair, so this is not a perfect square. If I ask you which is the least number by which we should multiply 325 so that it becomes a perfect square, then your answer will be 13. Why is it so? If we had another 13 over here, 13 into 13, so 13 would have a pair. Since it would have a pair, the 13 would come out of the root sign and 325 would have become a perfect square. Same way, if I ask you which is the least number by which 325 should be divided so that it becomes a perfect square, again your answer will be same, and that is 13. Why is it so? Because if this extra 13 would not have been there, we would have got only 5 and no root sign would have been there. So the least number by which 325 should be divided to make it a perfect square is 13. Now we have learnt the prime factorization method for finding the square root of a number. But you all saw that when we had square root of, say, a number like 2, square root of 2, square root of 3, the prime factor method will not be enough to find the square root of numbers like 2, 3, 5, etc. We have another method called long division method for finding square root of any number, which can even be a decimal number. Now this is a little tricky, so I request everybody to pay a lot of attention. If I ask you to find the square root of 324 by long division method, the very first step is, does 324 have a decimal? No, it doesn't. Okay, where is the decimal if the decimal is not there? The decimal is at the end of the number. Remember children, the very first step is from the position of the decimal, we will go right and we will go left and make pairs of 2 digits. From the decimal, go right, from the decimal, go left and make pairs of 2 digits. So from the decimal, I go left and 24 is a pair. Now this is 3. So I would like to add a 0 over here. 0, 3 would be another pair. But 0 at the beginning of a number is of no use. So 3 is alone a pair by itself. Now for long division method, please see this carefully. For long division method, whichever digit I will write here, same digit I need to write on the top as well. And the answer over here, as usual for division, has to be less than or equal to this number. So 1 square is 1. If I write 1 here, I will write 1 here also. 1 square is 1. If I write 2 here, I will write 2 here also. 2 square is 4. Can I write 4 under the 3? No, division does not allow that. So I will write a 1 here as well as a 1 here. Remember that for every pair there has to be an answer digit. For 24, which is a pair, again we will surely have an answer digit. Okay, now the same numbers have been written in both the places, the same natural numbers. Now 1 into 1 is 1. Subtract, you get 2. Which was the last digit I wrote in this column? The last digit I wrote in this column was 1. Write it again and add. 1 plus 1 is 2. Now bring this 24, which is the next pair, bring it down. Whichever digit I write here, same digit I need to write over here also. Same digits in both the places, and then this whole thing will be multiplied by this, so that the answer is either equal to 224 or a little less than 224. Okay, let's make a guess. This is a number ending with 4. Which are the squares which end with a 4? The squares which end with a 4 are 2 2s are 4 as well as 8 8s are 64. So we bring the 24 down. Now whichever digit I write here, I have to write it over here also, and this entire thing has to be multiplied by this. Suppose I write 1 here, then I have to write 1 here also. So 21 into 1 gives 21. Should I write 21 under 224? No. It's very, very small compared to 224. Okay, suppose I write 4 over here. Then I have to write 4 here also. Now how much is 24 into 4? 24 into 4 is 96. Should I write 96 under 224? No, it's not going to help. Okay, let's make a wild guess. This is ending with a 4. Which are the squares which end with 4? 2 square ends with 4 as well as 8 square ends with 4. 2 square will be less than 96, which is not of any use over here. So let's try 8 out here. If I write 8 here, I need to write 8 here also. 28 into 8 gives us 8 8s are 64, 2 8s are 16 plus 6 to 24. So wow, we have got our right answer, and at the top we have got the square root of 324, which is 18. Is it clear? Okay, now let's find the square root of a decimal number. Let's find the square root of 10.24. Let's find the square root of 10.24. From the decimal, we go right and we go left and make pairs. So from the decimal, if I go right, 24. From the decimal, if I go left, 10. Which is the square which is equal to 10 or a little less than 10? 1 square, 1, 2 square, 4, 3 square, 9. 4 square, 16, which we cannot take. So 3 into 3 is 9. Just above this decimal, copy a decimal for your answer as well. Now the last digit I wrote over here was 3. Write it again and add, we get 6. Bring the next pair down. Next step is, whichever digit I write here, same digit has to be written above this pair 24, and then this entire number has to be multiplied with this digit. Suppose I write 1 over here. I need to write 1 here also. How much is 61 into 1? 61. 61 is very less compared to 124. Let's write 2. 62 into 2 gives us 124. So I write 2 here. I also write 2 here and I get 124. Wow, we have got remainder 0. Since we have got remainder 0, it means square root of 10.24 is 3.2. Okay, let's solve one more sum. Let's find the square root of 7.29. What will you do for this? Again, from the decimal you'll go left and you'll go right. So from the decimal you go right, you get 29. From the decimal you come left and you get a 7. Which is the square which is equal to 7 or a little less than 7? 2 square is 4, 3 square is 9. We cannot take 9, so we take 2. 2 square is 4. Above the decimal, we need to copy the decimal. Fine. Which was the last digit I wrote here? 2. 2 plus 2, 4. Bring down the next pair. Whichever digit I write here, same digit has to be written in this place. So 41 into 1 is only 41. 42 into 2, 84. This number is ending with a 9. Which are the squares which end with 9? The squares which end with 9 are 3 and 7. So let's try 47 into 7. 7 sevens are 49, carry over 4. 4 sevens are 28. 28 plus 4, 32. Wow, we have got what we wanted. So we write 7 here as well as here, and 47 into 7 is 329. So square root of 7.29 is 2.7. We know that 1 is the square of 1. 4 is the square of 2. What about 2 and 3? Let's find out the square root of 3 now. Let's find square root of 3 correct to 2 decimal places. Now, I told you before also that from the decimal, we need to go left and right and make pairs. So, the 3 is alone. Now, after the decimal, we need to make pairs. Make pairs of what? When you divide and you don't have a new digit to bring down, what do? You add an extra 0 each time you divide. So same way over here, we'll be adding an extra pair of zeros each time we want to divide. We want to find our answer correct to 2 places of decimal. So after decimal, we need first 3 pairs of zeros. Mind you, for finding our answer correct to 2 places of decimal, we are taking 3 pairs of zeros. We'll find this answer and then round it off to 2 places of decimal. Okay, now 1 square is 1. Which was the last digit I wrote? 1. I write it again and I add. 3 minus 1, 2. I copy the decimal above the decimal. Now I bring down the next pair, which is 0, 0. Next, whichever digit I write here, same digit has to be written over here. Let's take 7 and we get 27 into 7. 7 sevens are 49 and 2 sevens are 14. 14 plus 4, 18. So we are getting 189. Let's subtract. Which was the last digit I wrote this side? It was a 7. So let's write again. 27 plus 7 is 34. Let's bring down the next pair of zeros. Now, whichever digit I write here, same digit I need to write here. Okay. Which digit will work? I think 3 will work. Let's try. So, 343 into 3. 3 3s are 9. 3 4s are 12. 3 3s are 9. 9 plus 1, 10. So let's subtract and we get 1, 7 and a 0. Okay, so now which was the last digit I wrote here? 3. Let's write it again. 343 plus 3 is 346. Let's bring down the next set of zeros. So you can understand that the next digit I should be writing in both the places is 2. 2 2s are 4, 2 6 are 12, 2 4s are 8 9, 2 3s are 6. Okay, we have got square root of 3 equal to 1.732. What was the question? The question asked you to find your answer correct to 2 places of decimal. Whenever you have such a question, you have to first find 3 digits after decimal and then round off to 2 places of decimal. So we need an answer till here. Now, is this 5 or greater than 5? No. So since this isn't 5 or greater than 5, our answer is 1.73. Okay, now let's do some sums where everything is mixed up. Okay, let's find out the square root of 729 plus square root of 7.29. We had already found the square root of 7.29. What was the square root of 7.29? Square root of 7.29 was 2.7, isn't it? This 729 we'll copy as it is. After that, you add them up. What do you get? On adding, you get 9 plus 2, 11, 2 plus 1, 3. So, this answer you can find out by long division. Okay? So, do this for homework. Okay, can you calculate this square root of 731.7? Please type the answer in the comment box, and if you have understood the lesson, do like the channel and subscribe to it. Let's meet for the next lesson, cubes and cube root.